Hello again. I am back for more of Odinmade Hero, the live programming series where I learned from Casey Muratori as he works on Handmade Hero and C++ and C, while I do it in the Odin programming language. Now, yesterday ended on kind of a bummer note. It just seems like it's always a mixed bag, like half and half. Some days everything goes perfectly. Half the days, everything works out fine in the end, and we do exactly what we set out to do. And then the other half of the time, half of every other, the remaining half, the other 50% of the time, we finish and there's some kind of bug and I have to go and track it down. But it's good because it's always a learning opportunity for me. And this time, probably the most interesting issue I've come across yet. It popped up while I was trying to track down some of this stuff. So I'm going to go through a few of the bugs because there was at least 4. There could have been more than that, but there's only 3 that I think are worth talking about. The rest of them were just kind of like me copying things into Odin incorrectly. Like I failed to name, well, actually, oh, thanks, Windows. I don't care about that. Never. I wish Windows would shut up. Anyway, yeah, I can't actually remember. Oh, yeah. So there was one bug where I just used the wrong entity. I was trying to check whether the sword was non-spatial or not, and I was checking the hero instead of the sword. And so that's just like a dumb sort of copy-paste bug. It's not really a copy-paste. I'm not copying the code out of Casey's editor, right? I'm typing it, freehand and trying to make sure that I type it in correctly. And then when I do something wrong, I have to kind of look and go follow the logic of what's happening here. It's like, oh, okay, I was testing the wrong entity. That's pretty straightforward. But some of these other things were less straightforward. Some of it was owed to me making a change where I'm encapsulating. I don't know if I have anything like this here. Like I can add it here, right? For the null position procedure that we've written. I could do it for the rest of these too, and I've been meaning to do it for pretty much every procedure, but and I don't even know if it's really what I want to commit myself to doing everywhere, but just specifying that result data in the procedure signature, and then you don't have to do this boilerplate like set the initialize the or declare the result and then actually assign it in the procedure body. I can just do that as part of the declaration of the procedure itself. And so I did that in a procedure, and then I forgot to actually use that declared result data, and I actually can't even remember. I think it was somewhere, yeah, add entity. Right here. So Casey called it the destination sim entity, right, that we're going to write out the simulated position to if we want to drop it in a particular place. Otherwise, we just get the relative distance that entity is from the origin, like the very center of the simulated region that we care about. And this should have all been result. But the reason why that's a problem, right? I mean, it's obvious that we wanted this to be the actual thing that we're returning. It's a problem because when we go to add the sword, right, we don't do this when we're just adding entities into the region that we want to simulate because we don't do anything with the result. But later on, we want to assign that result to the entity reference that is stored on the hero or the player, whatever, to the sword, right? So that was the issue there. And it was just a dumb mistake, but we'll see why that's a problem after I fix the first issue. And I think I set myself up to look at that issue first, but I just got sidetracked immediately, and so there you go. This I actually commented on. This led to a bug, and it's why, when we run the game, we don't see anything. All we see is a sad, empty, gray world. And then there's that little tiny yellow rectangle we're drawing up in the top left that was being drawn in by Casey. He added that in just to see if he could tell what was going on And now I'm getting notifications from Steam. Why? Why? I don't want that. Hold up while I... you know, I'll just turn Steam off. I don't need Steam. I don't need you right now, Steam. Okay. So, yeah, so that's a problem, right? And it was because, and I think this is like a subconscious thing, like the fact that I cannot, and I'll show you what I mean. I think I might have seen this issue where we were assigning the new position to be the reference, a reference to this new p init procedure parameter. But then I might have seen this error and been like, well, I don't want to have to overwrite, you know, the procedure parameter and then take the reference to it. But it turns out actually not doing that is what created that bug. All right, so now if I do this, we'll actually see everything. So that was a pretty easy bug to find, right? Once I remembered that I saw Casey was doing that, and I was like, that's not going to compile, and then it did, and I was like, what the heck? And then we moved on, and I just didn't bother to examine that again, and then I realized, oh yeah, that was the thing that came up. So we just have to shadow it, and I don't like doing it. It's like some kind of subconscious thing where it's like the fact that I'm forced to do that, to do things like this, it just kind of rubs me the wrong way, but I think that's a me problem, and I just have to get over it. And so the other issue now, right, is exactly what I was saying a minute ago, where if I try to throw the sword, you know, if I try to sling this rock, I'm pressing the action keys that we have mapped, and nothing's happening. And that's no good. So we can go into, I think it was in here, right, in the add entity call. Now I have to actually return that result. So we can go ahead and do that. And then we are no longer declaring that there. We're just assigning it. And so off we go. So now we'll see the rock, and you might have already been able to tell by now, but there's a whole other problem that is kind of irrelevant to everything that we did yesterday, and that is that the game is moving really slow. And Casey's wasn't doing that, so I immediately thought to myself, I've got a terrible, terrible bug. And it's not a terrible, terrible bug. It is an issue, but I'm not sure what to do about it yet, and I have a workaround that I can implement that'll give me time to think about this and what I want to do. But now, after changing, you know, fixing that procedure definition, now we can actually throw the rock, right? But of course, it moves slow because the game is running slow. So why is the game running slow? I don't have an answer for that question yet. I just know how to work around it, and I know kind of where the problem exists. I just don't know how to fix it. And I suppose it has to have something to do with the fact that, and I don't think I meant to leave this in here, but I'll come back to that in a second. It has to do with the fact that I've seemingly set up my sim arena code incorrectly, where we initialize an arena off the memory that was allocated in the platform layer, and then we create an allocator from that, assign it to the context's temp allocator. And so then everything we use, you know, that's transient or temporary, or everything that we allocate that is transient, we would get rid of at the end of each frame. But for some reason, using a user-provided buffer or byte slice, like you do with a buffer arena, for whatever reason, it causes the allocations that are happening to be super slow, I guess. I haven't investigated it that deeply, but I know that that's at least part of the problem, if not the entire problem, because when I switch to just using a static buffer and essentially, or not a static buffer, but if I use the arena init static call and then just give it the same size as the transient storage size, it just works, right? And so basically I'm allocating, at least I think, well, now it's not working. Why is that happening? Whoa. Did I not save that? Are we still in trouble here? No. Okay. Somehow I just failed to save. So now it runs smoothly. I don't know if it's actually running at the FPS that we want it to run at. One thing that's kind of weird is, like, as I throw the thing, as I throw the rock, I'm like stuck inside of it. So that makes me think that, like, collision is on with the rock, but then it can pass straight through the monster and these trees. So I don't understand what that's about. I'm like getting stuck in the path of the rock. So that could be another bug. But anyways, as far as this arena stuff goes, it's just, I don't understand why it runs smoothly when we create an arena just here, like allocating the memory for it here versus passing in memory that we've already allocated, you know, that byte slice. I don't understand why the buffer arena is slow and the static arena is fast to allocate those simulation entities. So that could just have to do with the way that I'm allocating that memory in the platform layer being different enough from how Casey is doing it that I'm not getting something, or I missed some important piece, some important aspect of that. And I tried to work around it, and keep using, you know, that transient storage that's already allocated. But nothing I tried worked. And one of the things that I tried, because I thought, you know, this must have something to do with it, is that if we go back to where the world arena is being created, right, and it's on the game state, so it sticks around, and it's permanent storage. Before, I didn't have this here, and I guess this should be, and I still don't even know if this is right. I have to go back and look at exactly how Casey is doing it to be able to understand if I originally just did it wrong. I wasn't thinking hard enough about it. But we could do world memory like that, and then just say that this comes off of, wow, that is a pain. It's just wrapping so much. Now I have to do this, I guess, and we'll say end of I don't know what to call this, end of world memory. Just so we can break this down and see what's actually going on. Because what I did before was just this, to basically take the memory, take the bytes out of the permanent storage that aren't being used by the game state, and then allocate, or rather create, initialize the buffer arena using all of that. But that memory actually goes into the transient storage. So by doing this, going from the end of the size of the game state all the way to the end of the permanent storage, if I go back into the platform layer here, that actually, and this wraps too, that's annoying. The permanent storage actually uses the whole memory block that gets allocated, and the transient storage goes from the end of the size of the permanent storage to the very end of that memory block. So they're actually shared. And so I thought maybe, you know, that was just wrong, and I did something wrong here by not basically saying, hey, the end of this memory is at the permanent storage size minus the size of the state. But what I actually think makes more sense than this is you could just start from the beginning. Well, no, because it has to be after the state, because we don't want that arena to use any of the data that's already being used by the game state. So it has to be after that point, but it can't go. I was thinking about this, and I think all I need to do actually, so what I was doing with this, right, is I was saying, okay, give us to the end of the permanent storage size minus the size of the game state, but I actually don't think that's necessary. I think we can just do that and get rid of that. And then this is basically just saying, right, that we don't want to allocate past the size of the permanent storage that we're using, because then that would overlap with the memory that the transient storage is using, and that's a problem. At least I think that would be a problem. And so that's why I wound up kind of setting an ending index for the range of the slice that we're taking out of the permanent storage. Because if this is taking up the whole game memory block and the transient storage overlaps with that, that would cause a problem. And I thought I did it as closely as Casey did it, and that would be a fine, but I didn't think about this at the time. So either I copied it wrong, or maybe Casey didn't think it all the way through. I'm more inclined to believe that I did something wrong, right? And also I'm just doing things with slices instead of, using a lot of the same mechanisms that he's doing. But I would have thought that it would all boil down to being basically the same thing, but that assumption was wrong. And it also made me think, well, what if I'm doing this wrong now, right? What if my permanent world arena, this part of the permanent storage that I want to keep around every single frame and not clear, what if something about that is wrong? But we haven't had an issue with slowdown with that, right? Probably because a lot of that stuff just gets allocated up front, and then you're not really changing, after you initialize, after you add all the entities, and after you initialize all the world chunks. I mean, there is the on-demand chunk allocation, which could be a thing, but I don't know. I don't want to think too hard about that right now, because this is complicated enough to think about as it is already. But the point is that I thought maybe by doing this, by sectioning off the permanent storage, because the problem, right, that really all of what I was just talking about is relevant to, is that I would have been creating two buffer arenas that are sharing the same underlying memory, and that's bad, because you would imagine that there would be conflicts, and if one arena overwrites the memory in another arena, like that would be bad. But for some reason we never had an issue with that. The only issue that I've been able to see, because it's not failing really, is just that it's really slow. But trying to do that didn't actually fix the problem, and so I'm just kind of at a loss. Using the static arena just works for now, and until I understand better why this is so slow, it's not worth it to. It's not. I don't think it should stop us from moving forward, because what's going to happen now, right, is we're going to create a new simulation arena every frame the same way we were before. It's just the mechanism is different, and it's not using memory that we've already allocated. So we're allocating more memory than we want to be allocating, but that's not a problem right now, because it doesn't stop us from continuing to build out the game. It's just a memory issue that I need to dig into, and be able to speak to and appreciate why that is going as slowly as it is, because I don't think it should be. It means that there's something wrong with how I've set this up, and it's on me to go and figure that out. So with all that out of the way, I can finally jump into day 67, where what was going on today? Making updates conditional, which I think basically means like we want to simulate. We're always going to simulate where the camera is, but we want to conditionally update outside of that to periodically update the stored entities elsewhere in the world. At least that's what I'm inferring based on that title. So we'll just see what happens and let Casey kick things off.
You're going to do start recording. Don't ask me why, that's just how things go. All right, hello everyone, welcome to Handmade Hero. The game, well, I was going to say the game, but it's not a game. It's a show where we code a complete game from scratch, live on Twitch, no engine, no libraries, just us and our typing fingers. We are actually pretty far in now. Like, we've done a lot of stuff. We have gotten to the point where we've kind of got a lot of our prototype stuff working, and we just finished up a pretty major change to how we were we've been sort of working on how we want our engine to be architected. And we just finished up a pretty major change, which is we changed to using these things called update, like simulation regions, which are like basically regions of space that we update together. That solved a bunch of problems for us. So I'm pretty happy with how it went. And we have one more thing to do with them that at least I think is probably something we should do with them. So that's what we're probably going to do today. And then we'll be moving on out of that system into looking at some other stuff. So if you would like to follow along at home and you pre-ordered the game on handmadehero.org, you should have gotten a link in your email, and that link allows you to download the source code anytime you want. So if you take a look here, we're on day 67. So you would unzip day 66's source code into a directory, and then you would be exactly where I am right now. So you could follow along with coding at home, which I highly recommend doing if you can, because it's one of the best ways to learn is to code stuff yourself. So let's go ahead and get started. If I remember correctly, we had pretty much finished up looking at the stuff that we wanted to look at, and we actually already sort of put in a little test of shooting an entity out from our entity. We don't really have any graphics for it or anything yet, but it's essentially just shooting a rock in place of something where we might actually put something, a little plate. And so that was basically all done, and so the only thing that really I want to take a look at was what happens in the apron of our update region, right? And so I'll just go over briefly what that was, just so because people may have forgotten, because we did a bunch of work with the update regions that had nothing to do with this part of it, but I mentioned it kind of briefly, and now would probably be a good time here, day 67, to go to the whiteboard, or I guess in this case blackboard, and draw out sort of what I was talking about. So basically, here's day 67. What I was concerned about, and the reason that I wanted to add one more thing to the simulation region, is we sort of have a couple different scopes in our simulation region usually, right? We've got the area where the camera can see, and we know that we always want to simulate that. And then we've also got surrounding that sort of a wider region, and that is the simulation area, right? So this is the simulation area that we want to actually simulate everything in. And the reason that I wanted that to be bigger than the camera area was just because I would like to be able to simulate people off screen at full speed and have it so that, if they did something, like let's say an AI over here sets a bomb, you would hear it, or it might blow through, like let's say there's a wall here, it might blow through the wall here. We want to be able to support any kind of like rich interactions immediately in the vicinity of the player that might be interesting for them to see or feel the effects of, even though that they're not on screen. What happened, the effects of what happened might sort of be off screen. That might spill onto screen, if you will. So these are our two areas, but there's another area that I wanted to include, right, which is just one more layer out, right, and this is sort of the collision area. And so what this was about was, if you are simulating everyone in this region, that includes obviously people who are sort of right on the edge of the region, right? There could be people who are sort of right on that edge, and those people may decide that what they want to do, if they're AI driven or whatever, obviously the player is going to be in the camera area, but the AIs are not necessarily. They may just be trying to do things like move outside. They may be moving in the direction that would take them outside of the simulation area. And what I'm afraid of is that if we just allowed the simulation to occur, as is, only using this as the boundary of the entities that are pulled in, there may be entities right there that should be stopping them from doing that motion, but those entities will never get seen by the collision detector because the collision detector is only working on the things inside the simulation area. And so what I wanted to do was say that we've got one more sort of boundary that's a little bit wider, and that is basically growing the simulation area by however much the maximum movement speed is per frame. Right, if that's 0.01 meters or something, I mean, who knows what it is? Maybe it's 0.1 meters. We'll figure it out, right? Whatever the in 1/30th of a second, how fast can the fastest thing in the world move? Or more to the point, we could even do fastest thing in the simulation area if we wanted to. But how fast is that? And then make sure that we make something that big, and that way we will know that we will include in the simulation area anything that might have essentially collided with with this object, right? So that way it'll stop that bug potentially from happening, which would be a bad bug for us to have. And it's sort of this is not entirely accurate either, because this sort of ignores one thing that we haven't talked about with our spatial partition, which is the size of entities, right? So size of entities is actually also something we need to think about, because what we want to do as well is we want to make sure that we bring in any entities. Like let's say that we've got these tile chunks, right? And the tile chunks are the things that we bring in, that we see what tile chunks are within our region. Well, if a particular entity, we're putting entities in the tile chunks based on their center, right? But the entity itself might have some size, right? The entity itself might be fairly large, let's say. I mean, it might not be that large relative to what we're talking about here, but it could be fairly large, right? And so if something could be fairly large, we also want to make sure that we would include it in here if its total size would cause it to sort of protrude into that area, right? Into the simulation area. Into the collision area. So really what we have is when we grow this area, we actually want to grow it by essentially a distance, both in x and in y, right? To make sure that the band is proper. We want to be able to grow by the radius of the biggest entity, right? And we also want to add to that the speed of the fastest entity, right? And really, we don't need to necessarily do both of these, because it's really when you combine the two. So what we could say is, for all entities, if you took their radius plus their speed, right? We want radius plus speed. We want to basically say the maximum of that. So we want the maximum, whoever's radius plus their speed is the largest, that is the size we want to enlarge our region by. And then we would know that everyone who might be involved in a collision would be sort of grabbed, right? And maybe we add an epsilon here in for safety, like because it is floating point. Maybe we don't want it to be quite so exact. Maybe we want to make sure that we've got a little bit of a buffer as well, just to make sure that we don't have rounding errors or something that are going to cause some kind of really bad problem. But in general, that's what we want to do, right? And so figuring out that number is not something we need to do now, because we don't even know something like that right now. We haven't defined all the types of entities that might be in the game. But what we would like to do is make it so that this is supported. And the reason that this is not supported right now is because things in this region, we could easily expand the region and run it. The problem is the things in this region would then get simulated. But we don't want to simulate them, because if we did simulate them, we'd then have to keep on enlarging the region to see what things they could collide with, and so on and so forth, right? So what we really want to do here is we want to say that anything that's inside this region isn't going to get simulated, right? It's not going to get a chance, it's not actually going to get its chance to do its move, whatever its move is, right? Only the things inside the simulation area are going to actually have the opportunity to move. And these things are just going to be brought in sort of as stationary static objects that cannot be moved, but that will serve as colliders for these other things, right? And so that's basically what we would have to do. So this is the one thing, like I was saying before, that I'm not super thrilled about, because it is a little bit, there's a little bit that I don't love about that. It's almost totally fine, but the one part that I don't love about it, just in my head, is what it means is that when two things collide, if one of them is in that static state, then they can't be moved. And whereas normally they would have been able to have been moved. So for example, we could have written collision routines before that would flat out just teleport somebody if we wanted to, and that's not really allowed anymore, right? It could teleport them as long as it was going to teleport them to somewhere inside the simulation area, but it wouldn't be allowed to teleport them anywhere outside necessarily, or other things like this, right? It certainly can't move them to outside this zone. And so it does impose a restriction. I don't know if that restriction would ever actually matter in practice. I can't think of a particular reason why we need to do that, but it is a restriction, whereas almost everything else we've done with the simulation regions has gotten us to a place where almost everything's restriction-free, and all the code can be written as if it doesn't even care about the simulation region. And that was kind of nice. Whereas that's one thing that does have to kind of be aware of it, and I don't love that part of it. But I'm not sure there's really much else you can do about that. So basically, yeah, everything has to basically have a marker in it which will say whether or not it gets to be simmed in that way. So let's go ahead and add that because
I also don't really know why that wouldn't also be a problem without the simulation region approach to things. Like, either way, wherever the camera is, we would still need to care about colliding with entities outside of it that aren't being updated as often. And I don't know how you would work around that problem. Like, the simulation region thing didn't solve that problem, but it also didn't cause it. But maybe that he just said that it either made that problem more complicated or maybe exposed it more as a problem. I'm just not totally clear on that, and that's on me to try and understand, I guess.
that's really the thing that I want to do today, to finish up those simulation regions. And again, we don't really have to do anything particularly fancy here because we're just doing our engine spec stuff. And we'll have plenty of time further on down the road to think about optimization and sort of other things that are going to impact this as we get more information about how the game plays. But I just want to make sure that the concept's in there so that we kind of are familiar with it, know that it's there, and so that when we make architectural decisions, we're aware of it and not just sort of going blind. So here's the sim entity flags, which are already storing our special states like collides and non-spatial. We have entity flag simming right now, which is basically a thing which says that it's in the sim region. So that's not what that particular thing means. So we also have an entity flag basically that I'm going to define here that means the thing that I just described on the blackboard. I'm not sure exactly what we should call it, but probably, I'm guessing, something like can update or updatable, right? I'm not sure what it would be. Can update, we'll say. Now, the thing that's a little bit strange about this, I think I might actually not do that now that I think about it. I think I might not actually do that. What I think I'm going to do is do it slightly differently than that, because the flags are something that gets persisted, and this is not a persistent thing. This is only true inside the sim region itself. So it's kind of like the storage index, which is it's something that, basically, and I should probably put a note here, these are only for the sim region. Once we start separating out this entity type into things that are stored where they should be stored and that sort of stuff, once we start breaking this apart, this is actually something that would go with like just the sim.
Do I want to split that out? I feel like I have to because he bothered to add a note. These are only for the sim region, and then just make that explicitly marked off. Up until this point, I was just throwing caution to the wind and grouping all of the things that are of the same type in the same little, section of the definition of the type. But here I'll make an exception. And so we have the storage index and then updatable. Is updatable, should it be like that? Or should it be like that? Maybe it's one of those things where they're both right. What does the internet say? Updatable, updateable. Updatable versus updatable with an E. Both of them are correct and acceptable. Evidently, Casey's spelling is more prevalent according to Google, so we'll just go with that.
Region part of things, right? Whether or not this entity is updatable. And so I think that's probably just a better way to do that. I think that's probably just the right, that's probably just the right call. So what I'm going to do is I'm going to go ahead and say that things that are updatable are going to get that marker, and then we'll come in here and we'll sort of do the most lightweight thing I can think of to do there, which is that when an entity gets added, right, what I'm going to do is I'm going to say that if that entity is inside a certain rectangle, then it's okay to be updated, right? So the sim region will store inside it, it's got this bounds, right? And then it also will have a new thing, which is basically update bounds, right? Or updatable bounds. And so that's the area where it's actually going to be allowed to, if someone's inside that, they will get like a tick, basically. And if not, then they won't get a tick. So I'm going to go ahead and say that the updatable bounds are in the sim region. I'm going to go ahead and here and check to see every time an entity comes into the active set, I will basically set, when I set storage index, I will set whether or not it's updatable based on whether it's in those updatable bounds. So I think we already wrote the code for this, right? If you remember down in begin sim, we're already doing exactly this operation. We do an is in rectangle, right, like this. And so all we really need to do is we need to do just that is in rectangle where we sort of do the check on the updatable bounds. Now
Okay, let me see if I can understand what's happening here. So we have our updatable bounds. That makes sense. It's just another rectangle that the sim region keeps around to say, hey, you can also update, pull in entities that are updatable within those bounds. Or you can pull in entities and say they are updatable based on whether they are in those bounds. Okay, and then inside of here is where we specify that right after assigning the storage index. Whoops, that should be result. And then is in rectangle. And what all does that even take? A rect and a vector. Well, we'll at least put in the region updatable bounds, and then I'm not sure what this vector is supposed to be, but he still hasn't done that either. Rockstars don't say prevalent. Rockstars wouldn't do what's prevalent. Prelevant? Just looking at the word makes me think, is that even a word? You know, rockstars come in many shapes and sizes, I'll have you know. Some of them are gonna say things like prevalent, and some of them are gonna ask what the hell that even means. You know, it's a wide range of vocabulary out there that, and you know, rock stars come in all shapes and sizes. That's all I'll say about that.
I don't remember what we did with mapping the world space. It looks like the world space gets mapped out here in this add entity. And so the only thing that I'm not sure about is basically exactly whether I should update these or not in here. I'm guessing I'll just leave them outside for now. So if you call add entity raw, you're responsible for setting that updatable yourself, and it'll assume that anything that gets added is not an updatable entity otherwise, right? And so assuming that it got added by the call that actually does know the location of the thing, then we will go ahead and set it at that point to be updatable based on the bounds check. So we'll do, oops, updatable, and we'll do dest p, like so. Now, I, again, don't...
Okay, so the dest p being the results position. Okay. Well, I guess I'll just go ahead and pull that then. Shoot. Now I'm all over the place. Add entity. Okay, in here is where we do that. And we pass the result p. So that's basically saying if the result is in the bounds, the updatable bounds of the region, gosh, yes, if the result from adding this entity here, if its position comes back as being within the updatable bounds of the region, then we mark it as updatable. And I guess I feel like it always would have been, because we're adding it to the region here at all. I see. The updatable bounds is smaller, right, than the whole bounds of the region. That's okay. I was thinking to myself that the updatable bounds would be outside, but that doesn't make any sense because everything should be constrained to the bounds of the region. I was thinking of things from the wrong direction. You like the rock stars that eat bat heads, okay? Not familiar with which band did that, but just by the sound of that, I think you're a Cannibal Corpse man. I mean, it's in your name, Devil, so I should have figured.
I don't really know if I actually need to do this at this point. I could just do this check when we're actually rolling through and doing updating, and then I wouldn't have to store anything at all. But the only reason I'm not sure about that is because I'm thinking that sometimes we'll want to mark things as updatable that don't necessarily have a position, things like this, if we have synthetic entities or something like that. And so I think I'm just going to leave it as a bool because obviously it's easy to do it that way, and that way we'll be able to quickly set it in the future if we want to. So I'm going to say that that's pretty much the entirety of it, and then when we do our simulation step, right, which we're currently still doing out here in handmade.cpp, we haven't pulled it out yet. When we're doing our simulation step, we're just going to go ahead and check that, and we're going to check to see if this thing is not supposed to be updatable, then we won't actually update it, right? Okay, so how should we do that? It's a little bit problematic at the moment, and the reason it's a little bit problematic is we're still going to want to render it potentially, or maybe we won't. Now I think about it, no, I guess if something's out in that region, we shouldn't be rendering it either. So really, this entire, I guess it's not janky, it's totally fine. This entire thing should just be skipped, basically for anybody who is not updatable. So we'll just say if the entity is updatable, then it can have its day in the sun, and if it's not, then it's not, and it doesn't get to do anything really at all. And so
Did he just wrap all of that in one big if? Looks like it. Okay, so way up here, before we do anything with any of the rest of the stuff, right? Calculating the shadow alpha here, getting out bitmaps, switching on the entity type. Before we even say reset the entity count or the group count, we ask, hey, are you updatable? That seems straightforward enough to me. Let's go ahead and wrap all of that. Oh, that's too much. Wrap all of that in that conditional, and there we go. So now, where are we setting the updatable bounds? I don't think we're doing any of that yet, are we? We only said if something is updatable. So like now what's left is to decide what the updatable bound should be, right? Ozzy Osbourne bit a bat's head during one of his concerts. I bet he got in trouble for that. Yeah, see, for example, Ozzy Osbourne, very colorful guy. He doesn't seem like the type to say prevalent. And that's fair, but, I'm not an Ozzy Osbourne type of guy. Not saying that I wouldn't listen to his music. I've listened to plenty of his music, but I'm just not. That's not who I am. I'm clearly not that guy. Because you can at least, he can't even pronounce words, let alone, half the time. Anyway, someone threw it on the stage and he thought it was rubber and was horribly mistaken. Oh, okay. Well, then it's. Yeah, how much drugs? How many drugs? How much stuff do you have to have in your system to bite off a bat's head and not realize that it's a real bat? Like, how much drugs do you have to have in your system to mistake a real bat for a toy bat? That is the question.
If the entity is updatable, then it can have its day in the sun, and if it's not, then it's not, and it doesn't get to do anything really at all. And so I think that's about it. What I do have to do now is figure out how big that updatable region is, and or really that's not true. We already know how big that region is. We got to figure out how to enlarge our other region, because remember, the update region is the region that we're already using. What I'm talking about is expanding it out a little bit. So really, the updatable bounds are actually the bounds that get passed in, right? And the sim region bounds are actually going to be those bounds plus some additional size, right? And so for now, like I said, we don't actually know what that size would be. We have no idea. So I guess we'll just say our safety margin, right? Our update safety margin will be something, and we'll put a to-do here that says important, Casey, and this is what the to-do we're doing right now, actually. Important, we want to say that this is calculated eventually, calculate this eventually from the maximum value of all entities' radius plus their speed, right? And then we will know that we are safe. So for now, we're just adding a meter, but in the future, we should add something totally different than a meter once we actually know what's going down. So we've got that. That should be basically enough. Now, so all we need to do is be able to, sort of enlarge those bounds. Now, I already told you about the Minkowski sum, right? I sort of was stating before that, I don't know if you guys remember when we talked about collision detection, I was sort of saying that a rectangle plus a rectangle equals another rectangle, right? And the way that you do that is if you imagine these were radiuses of the rectangle, right? So you have like half the width. This is the height over 2. This is the width over 2, right, of these guys. So if this was A and this was B, then this guy is just A plus B, right? So basically adding two rectangles together is pretty darn simple. You just take the center point, and the center point stays the same, and you add, well, that's not, I shouldn't say that. That's not entirely true, what I just said. Technically, if you were doing a real Minkowski sum, you'd actually add the points without considering the center point. So really what we want to do here is not really a Minkowski sum. What we really are sort of saying here is it is a Minkowski sum, but it's a Minkowski sum with a rectangle that's centered around 0, right? Which is sort of a special case. So yeah, that's sort of, I kind of threw the term around a little loosely, and I shouldn't do that. So really all we're saying here is whatever the width was of this guy, width and height, right? So if this was width 1 and height 1, and this is height 2, width 2, we just want to add those together so that we end up with something with h1 plus h2 and width 1 plus width 2, right? And so in our case, we know that we want to expand our additive region is just going to be that value, that 1 meter, right? The update safety margin. So all we want to do is take our rectangle and add the safety margin to to all sides of it, basically, right? So in order to do that, I think I might add a thing to our rectangle code that does this automatically. So that I can basically say that the updatable bounds if we want to produce the bounds of our sim region, what we're going to do is we're going to do something like a add width height, like something like this. And yeah, so we'll add, I guess, add radius 2 or something like this. And we'll do something where we just say, we'll add that safety margin, and that will go ahead and add it. And maybe we'll allow you to pass in a width and a height radius, essentially, to add to either side. So
it would be nice to not have to, write a whole procedure. It would be nice to do something clever with Odin's array programming, to where I could just basically say, +1, and then have it add 1 to both the min and the max. But then, yeah, I guess it wouldn't work, because you actually need to expand the bounds in the negative direction. And adding to it wouldn't, that would just be more like translating it, right? If you just added 1 to everything. So I guess it's not right, but we'll just say that safety margin is the width and height that we are adding. And over here, we'll add in this procedure, add radius 2. Just barely fits, and this wasn't right. Updatable bounds was supposed to stay the same. We're updating the actual region boundary that we are simulating all the entities inside of. And so now I'm guessing we want to add this to math somewhere in here.
So inside our math routines, we just have to go and add that, which will be really simple. Obviously, we've got sort of our rectangle calls here. All we need is a new rectangle call, right, where we do add radius 2, and that will take one of our rectangles, the source rectangle, right? I guess we'll just call that A. And then it will take two things. It'll take a radius width and a radius, oops, getting close to my head there, radius height. So again, really, really simple here. All we have to do is do a subtraction and an add. I guess I'll do it this way. From the min and the max of the thing that's passed in, the minimum corner of the rectangle will just get it subtracted, the radius, right? And the maximum corner will just have the radius get added. And that's it. And that should produce for us a new rectangle that's bigger by that much. All right. So
why does that not seem right to me? Add radius 2. I feel like, well, let's just go ahead and finish writing the signature. So we have our rectangle. I feel like I just want to call that rect. And we'll just go ahead and do what I've been doing. Now it's becoming a bit of a habit, right? Where I say this is my, in fact, I don't need to do that. I can just implicitly return that. I don't think I did that elsewhere. What was that? Was that inside of the entity code? Or was it the sim region? Where did I do this thing? I guess I'm doing it in a bunch of other places. It's like a weird shift in my brain that I'm gonna have to take a while to get used to. So that was in here. Let's go back over here. So we have our resulting rectangle where we're gonna update the bounds, and the min is gonna be based off of the initial bounds. Min, same thing with the max. And then we're subtracting, and then this should be radius. Well, should I just say width and height for brevity's sake? I feel like that's intuitive enough. These are both floats. And he did it like this, and this just doesn't seem correct to me, because I feel like you want, because this is changing width in the x direction, the width amount of radius we want to change in the x direction, and it's doing the same in the y direction, but I feel like this should be h. And that should be W. I don't know. That seems right to me. But maybe Casey doesn't see it that way, or maybe maybe he'll catch it later. I don't know.
Let's go ahead and check that out. There we go. And now I think that should just sort of do it. Again, we don't really have any good ways to test this at this point, but that should just about do that. And of course.
And so I guess all I have to do is the same, just see if this works, right? Because it's that simple. The updatable bounds get set. If I can spell updatable right. In here, if we're inside of that smaller boundary, yeah. And then over here, we're just setting it to false by default. Okay, I think I follow all of that. Let's just see if this works. I mean, like you just said, we can't really tell until we actually do some testing around that, but uh-oh. Something bad has happened. I'm stuck. What? Not like this. Wow, that was weird. I have no idea why that happened the way it did. I'm definitely getting like stuck inside of the bounds of the rock, and I wonder... Yeah, the path of the rock is like trapping me. If I try and run in the same direction as the rock anyway. That's really weird. I feel like that should definitely not be happening. It's like there's a collides flag set where it shouldn't be. Because the sword should explicitly not be colliding, right? We only have the non-spatial set by default, and then sometimes we take that off, but sometimes we add it back in. So that's just really strange. I don't know why that would be happening.
We're still doing this here. Yeah. All right. So the last thing that we have to do is we kind of got to figure out how we want to deal with like the sword and stuff. So should the sword still work? Because once we, do we have to make things updatable, or will they just automatically handle that? Let's find out, I guess, was the thing that's probably the easiest way to do it. So inside, where is it here? Where's our sword code? Handmade. I probably should also pull out this stuff into the sim region since it's pretty much where it's, or maybe into the entity file. So if we go through here and we're doing our hero, and then we're going to go ahead and do the update for the sword, and we do the make entity spatial thing, which moves it into the spatial set, should that gives it a position. So the next time through, you would think that it would get pulled in, right, to the simulation region and get updated. I would think. That seems like what should happen, but let's find out if this what actually happens. See, I'm not seeing a sword there, so I feel like I'm not thinking it through properly. I'm just trying to figure out whether we need to move things into the update set that aren't, these things are obviously not updatable or whatever. Would be, oh, well, no, never mind. I was just trying to, well, let me check. Let me go ahead and check. So what I just realized is we may never set positions properly on our thing that hoists things in from references, right? When we do load entity reference, what are we doing here? Yeah, okay. See, that's, yeah, so this is actually just a bug. This is just totally a bug. We never saw the bug before, but it was always there. When we load an entity reference in, we should go ahead and get its position set here, right? Because just because we happen to be loading it in via reference doesn't mean we wouldn't want to position it if it had a valid position, right? And so that seems to...
Or are we not setting it? Oh, yeah, I see what he's saying now, because we just pass in nil. Well, even if we pass in nil, I feel like this call will do... Yeah, because that's is going to be nil, and then it just gets the SimSpace position relative to where it is in the region. But then, yeah, I'm not sure about that.
Totally bogus to me, and not at all like what we would want it to do, right? So we definitely want that, the get SimSpace P call. We definitely want to do that. So it's sort of starting to feel like...
I mean, isn't it doing it right here? I feel like he's saying something that I'm not seeing, because it's exactly, he said we want to get SimSpace P. That's what we do. Right here. So I honestly don't know.
Yeah, well, no, because I guess the reason that we did it this way to begin with, right? The reason that we had the get sim space p pulled out is because we needed to do that ahead of time to see whether it was in the update region or not. So I guess we should just keep doing it this way. But what we should do, I think, is just go ahead and do that get sim space p right on the low entity. So we'll do it this way, right? Entity. I think we should just probably make it a fact that we always do this additional call when we're loading the reference, so that we know that we'll always actually have that guy in there properly. All right.
I'm lost on this one because it sure looks like that's what we're doing in this call right here. Right? If we load the entity reference and we do this, well, I guess, yeah, no, because on the first pass it should do it. We assign the pointer of the entity reference, and then we assign that. Well, we assign the, what is this? That's like the hash, right? Yeah, so this is the sim entity hash, and we assign the simulation entity to that pointer, and then we take the reference and point it at that pointer. Well, not point it at that pointer, but that's we assign the references pointer to the pointer in the hash after we call this, and this should just, because we're passing in nil, it should just do that. Because we're going to get a result back. The position we're passing in will be nil, and then it'll just be automatically done there. So I guess I just don't see what he's seeing. I feel like it totally is doing what it should be doing, but and to be fair, because was he just testing throwing the sword and he couldn't? I saw a bug. Yeah. Oh, that is really weird. Right, because if I do it right when I spawn in, if I try and drop the sword down, if I try and hatch a rock here real quick, right on spawn, I just get trapped in a box, and it makes no sense. Why can't I leave? But if I wait a second, then I think it just works. Yeah. So I don't know what's going on there, but we'll go ahead and do what Casey's doing just in case, you know, because I don't know if I'm just not understanding something or if that bug that we're seeing is related or what. So we do that and then get the sim space p on the region and the entry, and that's, well, should this be on the pointer? Well, no. Maybe you just meant to do this on the entity. Yeah, I'm not sure.
So we're going to do that get low entity, game state ref index. We will, actually this is low entity, we will get sim space p on him, and we will go ahead and pass that to this call, like so. And there.
Yeah, I really don't see what the difference is, because if you're just going to pass in the p here, then you're just overriding it with what the sim space p would have been assigned to here. Although I guess the whole updatable thing is a little bit different, because we're only assigning this here. Yeah, there's some missing pieces for me there, for sure. So we do that, and I wanted to specify that as the low, and then this, I guess, needs to be a reference. And now I wonder if by doing this I'll fix my issue. Yeah, he sees something there that I didn't see, and so he was trying to drop in the rock as soon as the hero spawned, and that was causing a problem. But I don't think he saw the bug where it was trapping him in a square. But now, when I drop in, I can start throwing the rock straight away, right, and I don't get trapped. So he was right about something, and I'm just, I don't see it. I don't see why. It's got to be, it's got to be the fact that we added in this updatable thing, and that assignment is only happening here. But I feel like maybe if you just did the same thing here, right, and marked it as updatable, because that's kind of exactly what we're doing, but we don't update updatable again here. I feel like this would do the same exact thing as what change we just made. I kind of want to see if I'm right, because if I'm right, then I think my understanding is correct. If I'm wrong, then clearly I need to get good and sit with this code for longer. But so we would not need to do that, and then we would just say that this is nil. I think so. I think that's it. Yeah. I mean, look, there's still something I don't understand about all of this, right? Which is that I'm getting stuck in the path of the rock while it's shooting, so to speak. But I'm pretty sure that's right. And I don't know if it matters that we are marking updatable twice. I feel like, well, what did I just do? I feel like what you could do... Yeah, I'm not going to do it this way. I'm going to stick to doing it Casey's way, because I feel like that because this code is being touched elsewhere, that doing things that way could cause a problem. And maybe there is just something that I don't understand, but as far as I can tell, that accomplished the same fix of being able to, allowing us to throw the sword as soon as we drop in. And then, I think I needed to change, where was that? Load. No, yeah, that's good. So, I don't know, just a bit of a strange thing to see, because I can see what he was driving at, but I can't totally understand why would we do this here if we could do it in here. Well, actually, yeah, because updatable would get just set to default, set false to default there. And because we'd be passing in a nil sim position here, you know, relative to the sim region's origin, right? That would never get set if we passed in nil. But again, like, you could just do this like we did, and that worked. I don't know. There might be something else going on that makes my thinking about that wrong. And basically what I'm looking for is a good explanation as to why you want to preset that sim space P to be able to pass it in here. Hey Crids, took a break for a bit, come back, and the code is so much crazier. Yeah, it gets deep, man. It's very, very deep, and it just keeps getting deeper. And I'm really trying my best. It's a tough thing, because I think I could easily spend a week on each day, each episode, in really cementing an understanding of the code of that day. But then it takes forever to get anywhere, right? I don't know which is a more correct thing to do. I get as good of an understanding as I can to where I have a general grasp on what is happening as each day progresses and we get deeper and deeper into the series. And some topics I'm going to hang on more than others because I think they're more generally applicable, like the stuff that we have going on with the memory arenas and the allocators that I've made from those arenas, and how those are being used and why that's causing slowdown with one arena type versus another. That is more generally applicable knowledge versus this very, it's not a huge entity system that's very elaborate, but there's enough complexity here that it's hard to really understand from beginning to end all the things that are going on. And even, I don't even know that Casey necessarily keeps that, all of that nuance in his head at all times. I think he's certainly got a better sort of grasp on the on a wider set of the nuance going on, but he still can't keep it all in his head, and that's when he makes mistakes. And part of that is probably owed to the fact that he was streaming and talking through the explanations as he was doing it, rather than just getting in the groove and just being in your own headspace and not having to, because it gets really difficult to communicate what you're doing in code while you're trying to do the thing. Like, you almost have to like redo the process of what you're coding over and over again to be able to find the most succinct and coherent way of explaining that, because I fall into that trap where I'm trying to explain what is going on stream as I'm trying to understand what the code is doing, and I feel almost every single time that my explanations are inadequate to myself, and I'm the one doing it. So like, if you're somebody that's watching, you know, I don't hold out a lot of hope, but I think there comes an inflection point where I can explain things and answer questions myself, and that's kind of like the road that we're on. And also we'll get into more topics that are, again, of more interest to me, that where I want to have that deeper understanding, because those are just the things that interest me, right? So those are the kinds of problems that I would tackle on stream and focus more on in my spare time. But yeah, and this is related to something that Casey said in a video I watched not too long ago. I'm trying to remember. There's an interview he did with somebody, or maybe it was just like a stream that he did, where he expressed that the thing that makes games unique as far as like the programming aspect goes, and not even really just I guess specifically the programming aspect of it goes, is what he said, is that it's very deep and wide, whereas a lot of other sort of programming disciplines, I guess you could say, they're very deep about one peculiar thing. But in games, you can get very deep on like the networking side of things. You can get very deep on the rendering. You can get very deep on just like the sort of game logic aspect to things, I suppose. And then you get very deep on entity systems. And I think that's where the interest on entity component systems kind of comes from. But that's a topic that I won't speak to at all, because I've never had a firm grasp on what that even means, and because it just seems so generic of a descriptor that it could apply to very many things that all work and behave very differently. So yeah, the code is crazier, and it's just going to keep getting crazier. I'll leave it at that.
There we go. That's about it. And also, does add entity, I don't even know where this is actually getting called now. I guess it gets called only when someone actually does have that SimSpace P, so it's a little bit weird. Yeah, it's a little bit weird, and we just did that to do as well. So let's take a look. I feel like that could be simplified a little bit. I feel like we've got a little bit more than we need now in terms of stuff, but who knows? It's not that much. We'll see. All right, so there's that. So that's fixed, and that's what we would expect now. And I think everything's pretty good now. I think we're pretty happy with that. I don't think we need to do too much else. So yeah, where are we on time? We still have a half an hour left. So I think maybe what we should start doing now is start actually going back and looking at the stuff that originally motivated this sort of things, which is just having hit points, being able to do some stuff with that. Having trouble getting the water in my mouth today. That's not good at all. You'd think that after a while, I'd be good enough drinking from these things that I wouldn't have that problem, but you know, it's not true at all. Absolutely disastrous here. The problem is, of course, I suppose it's not almond milk. I was drinking water from this today, and so, you know, at that point, the viscosity changes, obviously, is really the problem. It wasn't my fault. It was this different liquid. So yeah, so I think probably the easiest thing for us to start playing with then at this point is just maybe like working on some of these guys. I also feel like our familiar has stopped going because I don't know if we ever ported his code. So I feel like we could do some of that work. So maybe let's just go through and just tidy up some of this stuff, get everything ported, make sure we're working. And
that's weird. I could have sworn I thought I saw the familiar working. Like earlier today, even. Yeah, he's working for me. So, not my bug.
And take a look at like the Monstar and the hit points and that sort of stuff. Because now that we've taken care of the sim region stuff and we've gotten that sort of in there situated, now might be a good time to kind of deal with some of this stuff. So let's see. Our familiar does not appear to be working properly as far as I can tell, because before our familiar would follow us around, and he's totally not following us around, right? Like he's not following us around at all. So why isn't he following us around? Let's take a look. So when we're in update familiar, and I guess I'll also take a look at the code that calls update familiar. So in update familiar, we're just getting normally called as I think we would, and we are passing a sim region entity in a time step. We then say that we're going to search within 10 meters. We go through here and we search for inside. Oh, well, that's pretty obvious. For some reason, we never incremented the test entity pointer. So we did port it. We just ported it badly. I'll go ahead and recompile that.
So yeah, I didn't have that problem because This loop just gives me the index into that entity that I care about inside of the region, and then we just run off and say, do we have a hero? This is dead code right here. Well, it's not dead. It was part of a check that we were supposed to make where it was like if a hero is closer than a familiar, like this was all getting really complicated, but all this does is purposefully slow down the rate at which the familiar is flying. And the idea was that rather than getting stuck together permanently, if a hero walked past the familiars, because he wrote some quick code to like have them kind of flock together, almost like, I don't even know what you call that. It's like a kind of like how hairballs rolling around, they just kind of somehow get sucked into each other because of magnetism or whatever the reason is. It's been a while since I took that grade school science class, but as a hero walked by, like they would just be pulled more strongly to that hero is what this code was supposed to be. But now it's kind of goofy.
Let's see if the familiar, there we go. So we weren't looking through all the entities. Simple bug, problem solved. All right, so there's our little familiar, and off he goes. Makes sense. So let's take a look at the Monstar, and let's take a look at the collision detection, the sword, and that sort of stuff. So it looks like, we've got this non-spatial flag here, and I feel like for the most part, that doesn't really need to be, like, depending on how we decide to do things, we wouldn't really have to check for this at all, right? Because now, since we only pull things into the update region, if those things are actually, we only call the update function if something's actually inside the update region. If the
It's just really bugging me that we're stuck in the path of the sword. Makes me think that maybe one of these checks that I did was wrong. Because, well, it works everywhere else. That's what's weird about it. The collision detection properly checks, hey, all of these trees, they collide. This floating head collides. This disembodied torso collides. We can walk through into the next room. All of those things are working. But why is it that it thinks that we are... Yeah, it seems like it's passing this check and it's saying, hey, there's a sword there. And because, and it makes sense that it would happen when the sword is spatial, right? And the sword is spatial when we removed this flag from it while we are simulating it, traveling through space after the hero has shot it out. So yeah, that's just weird. I want to look into that, and I want to see if my old Zig code had the same problem.
Sword is not inside the update region, it wouldn't get called. So, this may not even need to exist anymore, right? If I were to get rid of this, I don't think it would matter anymore, because we sort of got rid of the need to even have that concept now, because since yes, they get brought into the simulation set, but the simulation set has a concept of updatable that doesn't include any entities that would have had non-spatial set. So that's kind of interesting. I wonder if that will allow us to simplify some things even further. I hadn't thought about that, but it's kind of interesting and kind of neat. So kind of an accidental thing that happened there, but I'll take it. So when the sword moves, right, we're calling move entity on the sword. And what we want to do now is we want to figure out a way that we can sort of use our collision detection to actually do some kind of an operation when the sword hits something, right? And we talk a little bit about having a table that would record when things got hit and that sort of stuff. So let's go take a look at that stuff, because we want to be able to do all that stuff, so we might as well just pick up where we left off way back when and actually start coding some of that. So we've got our move entity call, right? And the way the move entity call is, it does the equations of motion for this thing. And you know what else I should probably do while we're at it, while we're just cleaning stuff up, because I'm thinking about it right now? We've got like this DZ update stuff. That should probably be inside move entity as well, right? It's like the move entity should update the Z coordinate, I feel like, for stuff like so. And so, for now, I would say we should probably do this in here. Now, we might want to integrate it in a little bit better than it's been integrated in right now. But let's just go ahead and put that there for now. And then that should allow us to have, our Z get handled along with everything else inside the move call. And that seems just better, right? So let's just do that, and that's done.
Okay, so I'll just go ahead and follow suit here. Make sure I take the right code and none of the wrong code out of here. It looks like it's basically just this, right? And that's all of the change in Z stuff. So we take that, go into the move entity call, and then it looks like you dropped that in right before we do the iteration for the collision detection. So I'll go ahead and make sure that didn't break anything. And I think we're okay. Slide that bug. Yeah, that's super weird. My hesitancy about it is that, like, if Casey's code has that bug too, then, you know, it's reasonable to think that he would discover it and then, you know, show how to fix it and diagnose it. But at the same time, like, that's a good learning experience for me to dig in and really figure out why that's happening, because it'll just allow me to see, you know, some piece of the puzzle that I don't already see. But, like, do I want to take the time to do that if he's going to wind up fixing it? But then again, I don't know. If he doesn't even have that bug, then it really is on me, and I'll never know why if I don't fix it. So it's like Schrodinger's bug or something like that. Is the bug alive, or is it not? I don't know.
So what I was going to say was, when we do our move entity call, right, we're doing this test for collision, and, you know, it's totally fine. We haven't really done a real one yet. It's not a really very it's not a complete collision detector, but it does let us know when things hit other things. And when things hit other things, we have the option of doing something about it. And obviously that's what we would want to do in the case of the sword. But what we have is we've got sort of our colliding flag doesn't really tell us everything that we might want to know about what we should do to handle the movement of this entity, because we really want two things for the entity as far as collision are concerned. We want to be able to do collisions, and we want to be able to respond to collisions, but those should be separate things. Some things, right, may want to actually stop when they hit things, right? Like, we may want, you know, like, for example, the reason we originally wrote this, when the hero hits a wall, we want him to stop moving. That's one thing we can do with collision. But another thing we might want to do with collision is allow the player to pass through the wall, but just, you know, do something about the fact that, right? So imagine not a wall, and instead this time it's a floor plate. We may want them to be able to walk over the floor plate, but we want to do something in the case where they have walked over it, right? So really, we want to start breaking our collision response into multiple pieces, which is detecting the fact that it happened and responding to it are not going to be the same flag, or not even going to be the same, like, idea, really. We want to separate those out into two different things, because the sword might be an object that works exactly like that. It may not stop when it hits a monster. It may, you know, pass through the monster and do damage, but do damage to other monsters as it goes, like perhaps it has piercing and that sort of stuff, right? So we want to be able to sort of have individual control over which one of those is going to happen. I did the drinking correctly that time. So how do we want to do that? Well, it's pretty easy for us to do something very simple, right? And so the complicated part is actually going to come in how we sort of want to break this routine out into something that's a little more usable by the higher level code. And so we've got a couple different things to talk about here, all of which are very, very intricate and complicated. And so we might not do all of them right now, but we'll sort of talk about them. So the first thing that you'll notice is inside a single collision, inside a single move call, we have an iterative system that's working, right? And I'm going to go ahead here and draw this out for you, because it's been a while since we did this. I just want to make sure people remember. So let's say that we have, well, actually, I'll draw it a little bit differently. Let's say that we have something like this, right? No, that's not what I really wanted. Oops, let's bring that back. Okay, so let's say that I have something where I've got a wall like this, and then I've got another wall like that, right? And the player is trying to move like this, okay? And so when they hit this wall here, we are stopping them, and that's good. But we're allowing them to continue to move along the wall, right? And what we're doing is we're saying, well, wherever you could have moved to if you had moved the regular direction you were going, will allow you to go that far along the wall, right? But the problem is there may be another wall, like in this case. So we would then do another collision step to find where you had hit that wall, right? And so really there are two iterations inside a single call to move entity. In this case, we would have had two iterations, one that moves the guy to here and hit this entity, whatever this is, right? And another that moves it to here and hit this entity, which could technically be a different entity, right? So this could be entity A and this could be entity B. Now what we want to do, what we want to start doing here, like I was saying, is for entity A's collision, we may want to have a response, right? We may want to do something when A and whatever our entity that we're moving are, we'll call that E. When E and A collide, we may want to do something, right? And then furthermore, when E and B collide, we may want to do something. So we're now in a position where we have sort of this need to do a dispatch, but we need to do the dispatch from inside of an iteration, right? And so
I'm sorry to interrupt Casey's collision detection stuff, but I just kind of noticed something that I think is my problem. And in fact, if I back up and look at his code, because I want to restart and listen to what he has to say here. I got distracted being a fool. And, well, that actually looks like he might have a similar issue. So what I realized looking at these checks is that I'm checking the same entity that we are testing other entities against in the region right here. And the player which would be the entity we are testing, right? We passed this check, and I added this to do here because I thought I was going to add it to do and then come back to it later. But I think, we wanted to test the test entity because here it would be the sword that it would be testing against. And then over here, Casey is actually testing against the non-spatial, not the non-spatial. Casey is testing against the original entity too, but I feel like we want to be testing against the test entity here as well. And so maybe he had like part of the issue there in his code, but I definitely had this issue. And so I don't think he had it. And now if I do this, I think that we won't get stuck in the path of the rock. Are we ready? Let's see. That was it. Now I can shoot the rock, and then I can veer off and escape its flight path. So that feels good. I'm glad that I spotted that. I was looking at this, and I was like, why am I testing the flags of the same entity twice? Shouldn't this be the test entity? And it should be. But again, I don't know, because Casey left this check like this, right? He's testing against the entity that we are trying to move, right? The entity that gets passed in here. He is checking whether that entity is spatial, and I feel like we should be checking the test entity as well because we're doing the same thing for the collision. So anyway, I'm pretty happy about that. That's I'm glad that was easy.
And what we're doing is we're saying, well, wherever you could have moved to if you had moved the regular direction you were going will allow you to go that far along the wall, right? But the problem is there may be another wall, like in this case. So we would then do another collision step to find where you had hit that wall, right? And so really there are two iterations inside a single call to move entity. In this case, we would have had two iterations, one that moves the guy to here and hit this entity, whatever this is, right? And another that moves it to here and hit this entity, which could technically be a different entity, right? So this could be entity A and this could be entity B. Now what we want to do, what we want to start doing here, like I was saying, is for entity A's collision, we may want to have a response, right? We may want to do something when A and whatever our entity that we're moving are, we'll call that E. When E and A collide, we may want to do something, right? And then furthermore, when E and B collide, we may want to do something. So we're now in a position where we have sort of this need to do a dispatch, but we need to do the dispatch from inside of an iteration, right? And so the normal way that people handle this is with a callback, right? What they do is they come in here, because this is the part of the code, excuse me, inside this iteration here. We would want to do this inside the iteration, right? So when we do hit entity, this right here, here is where we would process whatever the entity that you hit. Here's where we process it. So what they typically will do here is they do like something where we do like, process collision, right? And they would call out into something that handles the collision. Now, I don't know if we necessarily want to do that, right? We might not. What I do know is that typically it can be a little bit annoying to have it work in a callback fashion, because a lot of times callbacks lose a certain degree of important flow control that you might want. Now, this is the first time that this has really come up, and so I think I'm going to spend a little bit of time talking about it, because we do have plenty of time left and we don't have anything particular that we need to get done on the stream, so now might be a really good time to talk about this. So let's talk about it. So let's talk about callbacks, right? So basically, what we have right now is we have a pretty nice system. We have a function that's called moveEntity, and anyone who wants to can call moveEntity to move their entity, right? And we can use that in any way that we want. There's no restrictions on what we can do with it, right? We can just do it, and if we have an entity that we want to move, we move it. If we don't, we don't, and we can also call moveEntity multiple times if we wanted to on a single entity, or move different pieces of an entity with moveEntity. We can do all kinds of stuff, right? There's all kinds of things we could do with moveEntity. And the reason we can do that is specifically because it doesn't really do anything inside it except the one thing, right? All it does is it moves the entity to wherever it should have been, given the collision that's involved in the simulation region. So a callback introduces something into here that's, and this is true of any situation where you introduce callbacks. Any time that you have something that does an iteration, right? So typically there's some kind of complex iteration involved, right? And we saw the iteration, it's a collision iteration, but there's other iterations, like let's say that you had something like a binary tree, or you had something like a XML file, right? And you've written an iteration that iterates over it, but you want to do something on every node, or you want to do something when you find certain things, or you want to test it. Callbacks are a typical way that you introduce that functionality, because you can sort of pass the callback in, right, or something like that, to the function, and then the function will sort of do something, we'll call that and allow that to work. Now, other languages and also in C++11 have slightly better versions of this, right? They have closures and lambdas, right? I don't know how you spell lambda. Lambda? Yeah. They have other things which allow you to access different stacks and kind of do some other things that make callbacks a little more painful. But the bottom line is callbacks are always kind of not really what you would prefer to have happen if you could have written the code to basically never have to share anything, right? And why is that? Well, the reason for that is actually pretty straightforward. If I have a piece of code, if I have code A, right, and I wrote it, and then I have code B, and I write that, right? Code B is the thing that does the iteration. I want to be able to share, with I got code C down here. I want to be able to share this iteration with both code A and code B. I'm sorry, code C, right? I want to be able to share, you should probably know these better. Let's call that B and that C, right? Or better yet, code S for shared. So I have code A and I have code B, and they both want to use code S, right? They want to use that iteration, but they want to do different things when the iteration happens, right? So the reason that callbacks are kind of a nasty way of doing this is it forces whoever wrote code A, right, to basically bundle up something that's capable of doing whatever it needs to have being done and send it over to code S, right? So that code S can actually do whatever the thing is that needs to be done. Now, it basically introduces this nasty coupling of the S code understanding the sorts of things you might want to do in A and B, right? And preparing it such that it can use whatever this black box is that's been passed. Furthermore, it assumes that code A has to be able to bundle up all the stuff it might want to do, which is kind of cumbersome for it, right? And it has to sort of have this sort of notion of context and all the things that it might want to do, bundle them all up and then send it over, right? Really for no reason. Because if we were only going to write one piece of code, let's say we just had code B and code S, right? B, S. Okay, let's not say that. Let's say we had code A and S, right? Or I could feel like I could do code SB, put them the other way around. So let's say we had codes S and B, and we were just writing, that's all we were writing. We never had to share it. Then what you would do is you just write the iteration code, right? You just write this, and then whatever this code that was going to do, whatever it was going to do, you'd put it right in here, and it could be made nice and clean and optimal, and everything would be great, because everybody kind of knew exactly what was supposed to happen, and you didn't have to have this part where two sides of the program were written without knowing what the other person was doing, or without being able to really change what the other person was doing, and that's where you get some of this callback nastiness comes in. So again, these things make them a little bit easier because you can share stack frames. There's some stuff that you can do in languages that support other things. And again, C++11 adds these guys, I believe. I don't think it adds these. I don't really know. I don't stay up to date with C++11 much, but.
So we're actually doing, we're using a callback already in the Odin code base. If I come back to make sure I'm not muted. I don't know why I would be. I don't remember muting myself. But there have been times where I'm muted and I don't even remember muting myself. So it doesn't hurt to be too careful. Somewhere in here, there's a callback. Yeah, and I'm doing it for the audio. And you can actually see this code inside of the platform layer that I've posted up to my GitHub. And I think it's in the description of the stream. But we define it here, right? And then it gets passed over here in this, as part of this audio spec type that's in SDL. And it's just, that callback that gets called when the audio needs to change the region sizes for this ring buffer thing. And the Handmade Penguin stuff really explained this in more detail and probably more well articulated than I can. But basically, it's just a way of keeping track of where we're at in the audio buffer, which we haven't worked with any audio, and I don't know if we'll ever work with audio as far as the whole Handmade Hero thing goes, because I don't know if Casey ever comes back around to audio. He hints at it a few times, this notion of adding sound to the game, but that might be something that I have to figure out on my own someday when I'm so inclined. But that's another thing that I actually have a great deal of interest in is working with audio. So, but that's neither here nor there. The point is that I'm using this once here, and this is just a very different application of this sort of thing that I'm used to. But the idea is that you can write whatever you want to have happen when the audio is being every single time I think you get a lock on the audio, which is happening. Where is that? Is it even called lock here? It's like SDL. Gosh, where was that? Yeah, here we go. We lock and unlock the audio device, and we do that so that we can reliably fill up the sound buffer without getting, mess up audio that sounds terrible, right? And it's a lot trickier than I would have ever guessed before starting to work with this sort of stuff, before working with audio in code. But it's a much more nuanced case, I guess, compared to what I'm used to dealing with when it comes to callbacks, which is usually just I have one implementation that calls some API where I need to get data or I need to update something somewhere outside of my purview, right? Or maybe it's like it's something that takes a long time to get a response, and and by a long time, I mean like 1 second. Like it's going to compress a file, or it's going to change the size of an image, change the resolution or something like that. When I'm testing, I don't want to have to wait for that to execute, or if it's something that I can't interface with, I just want to pretend that I had it's like kind of like the whole happy and unhappy path, stuff that test-driven development kind of advocates for, that you want to write tests for. And I do a little bit of that, but I'm certainly not dogmatic or gung-ho about it at all. But I do it just enough to be familiar with this sort of thing. But it's fun for me to see anything come up that I actually have a little bit of experience with, because it's like every single time we do something new, like entity systems and rendering, I just feel like a fish out of water. But it's nice that Casey finally talked about something for the first time in a while where I'm not totally lost.
Pretty sure they added lambdas, put it that way. And so really, if you can avoid it, though, it's nicer if you can get out of this business altogether and just allow whatever this was that you're going to write in here, this S code, the thing that does the iteration. It's oftentimes much nicer if you can just expose that as a sort of tool that these guys can use to write an iteration, right? So basically, whatever this was doing, if you can package it up as an iterator that these guys can use, then you are able to sort of reverse that flow instead of having to pass this into here. If you can just fragment this iteration code up into basically 2 parts, right? The initialization and the stepping through the iteration. If you can break that up, that gives you a lot more flexibility to write the code on the outside any way that you wanted to without having to deal with this sort of black box passing kind of nonsense that's just, makes life a little more difficult for everybody. And so what I would probably recommend doing, depending on how we decide to go forward with this, and I'm not sure exactly how we will decide to tackle it, is if we decided to keep calling move entity the way we've been calling it, I would probably go ahead and break this iteration out into its preamble. So I just take this portion here, break that out into something that basically sets up a struct that has these variables in it, right? And then I would have an iteration call which does this stuff. And that call would just return the hit entity. And you could call it as many times as you want, and then when you were done, you would say finish, right? And it would do this postamble. That'd be a really much cleaner way than like introducing a callback in here that does the collision on the times when that happens, right? So that's one way I could go. I'm just trying to give you the full what's in my head when I'm thinking about this. So that's one way I could go. And I'm totally fine with that. That seems like a good way to go. But there's another way I could go, which is if moving entities is something that's always going to be handled in a central local, like a central logical fashion. So basically, moving entities just isn't something that's allowed to be done pretty much ever, except by the centralized concept of the update. Then what I could do is totally change how this works entirely, and say, when you do your update call, you are not allowed to move your entity. You don't get to call move entity. What you do is you latch in what you want your acceleration to be, because that's what your control is, right? You get to set your acceleration, and then once you've set it, the movement will happen automatically somewhere down the line, right? So that's another way I could go. And if that's the way I could go, then this doesn't become a callback situation, because there's only one thing that can ever happen in here, which is this is the place where dispatching entity collisions actually gets processed, but it's always going to be processed exactly the same way, so we don't have a situation where we've got to hoist that out. Now, to me, just on the whole, that kind of sounds like the right way to go. And the reason that I think that kind of sounds like the right way to go is because in the future, we don't know exactly how we might want to do our actual updating. We might want to try and do some simultaneous collision solving where like multiple people are moving at the same time and we find their intersection points, that sort of stuff. Who knows what we may want to do. And so what I probably don't want to do going down, what I probably don't want to establish as an early on policy at this point is the concept that entities all call move entity themselves. I think I might want to take that out of their hands and say spatialness is just an inherent aspect of gaming. We will handle it in a centralized fashion. You aren't really going to do that, right? So we're going to do that for you. And basically, like, we'll just have a flag, an entity flag, which says, I'm an entity that can move or something. And that, or maybe they don't even have to have a flag. It's just whether if acceleration was set, then it goes, right? And to me, just thinking it through, I feel like that just feels a little bit better to me. It feels a little bit more like probably what should happen. So I think that's what I'm going to start with. And then if it turns out that that doesn't work, then we'll sort of address it a little bit further on. So for now, I think that's what I'll do. What we'll sort of say here is maybe we'll just say when we're doing our entity update for now, again, this is not at all set in stone. What we'll kind of do is say, let's set this move spec and this DDP here. Let's go ahead and say that those are going to be things that are sort of set in the entity's update, and then the actual movement call is not something that the entity actually gets to deal with. That's something that happens somewhere down the line. So like this stuff right here, that doesn't get to happen. Instead, what happens is
just want to make sure that I'm staying on top of where this is going. I thought he added these just now, but they're clearly already there. Same with the DT. But if we go back down to that switch here, we have the alpha. He's dropping in the move spec. That's going to be a pointer to one of those. And then The DDP is a vector 2. And how did this happen? Why are we wrapping right here? Ugly, go away.
This move spec up here, right? We'll set that to the default move spec for now, like so. And then the move spec will get set in here for each individual entity, and then this doesn't actually get to happen. So the Con Hero DDP, excuse me, becomes that DDP, right? So this starts out with no acceleration. The Con Hero DDP, that gets put in there. Actually, I guess, and the entity DZ would also be that as well. I would say, no, that's discontinuous, so that's fine. All right, we'll talk about that later, because this is our stupid jump code. It shouldn't even be in here. But yeah, it's lingering. So yeah, so
all right, so we can just, wait, what's going on there? So that returns not a pointer. I see, he didn't wind up specifying it as one. So we get that. This is just going to be zeroed out, and over here, we don't grab that, we just set it.
Instead of calling move entity, that move entity call will get pushed out to the bottom, right? We do that here. And what we instead we're going to do is we're going to say that this...
Hold on, so he's going to do that after kind of processing the render pieces and also the sword stuff. So the ground point stuff, yeah, that's over here. So we just do that out here, and that's kind of interesting because we are doing those move calls elsewhere inside of all of those update procedures, so I mean that's definitely gonna be consequential here.
Do that here. And what we instead we're going to do is we're going to say that this right here just sets what we want the acceleration to be, and that's it, right? Similarly, the rest of these guys don't get to do that either. They all have to do the exact same thing. And I'm also wondering why we even bother having these. I don't know why I have like these calls separated out. These seem like kind of useless functions to me. These should just be inside the switch statement, and this switch statement should be out here in the handmade entity. But you know, what are you going to do? Sometimes you can't win them all. We'll think about how that's structured a little bit later on. So what we want to do here is, yeah, we want to be able to sort of have this worked out. And maybe, you know what I could do too? I could sort of say that move spec... No, I'm not going to do that. All right, so when I update the familiar, it wants to be able to set a move spec as well. And it's going to have to set its DDP as well. So I need a convenient way, for as long as I am keeping these guys out here. And you can see why I don't love having these out in separate functions for no apparent reason. I can't just go ahead and set these things that I want to set, which is kind of annoying. So I may just go ahead and just stick this in here. Let's go ahead and say that we're going to go ahead and, there we go. So now I can just set my move spec directly. I can set my DDP directly. Of course, swords don't have a DDP. We can get rid of these guys. That's gone. We can get rid of this. That's gone. So,
okay, so just basically making that entity code obsolete now. What was this? Is this the sword? Yeah. So we just take that out, but we're not going to actually set the move spec over here. We just replace that call with all of this. And yeah, I guess, well, here I only override the speed because everything else is just set to the default. So that's good. What the heck was that about? This is a sim region. Well, I mean, we don't need to do that call anymore, right? I think he's going to get rid of that. And so now an update familiar, same thing, except we're not going to copy that move entity call. Replace that, and throw all of that in line. We don't need to do this. Oh no. Oh, because all of these are working off the sim region now. So I think that's good. Or not that they weren't before, but we're calling this the sim region here. whereas I was just abridging it to region inside of those update calls. And pretty much everywhere else. We only call it, you know, sim region by its full name here in the main game loop. So I guess that's just good now. We're going to have to do the same thing for those other calls, but what is with all this wrapping? How did I not notice all of this before? I have no idea. Maybe I'm too zoomed in. I must have... Oh, it's probably because we had to do this, right? We had to push everything over because we're checking to see if something's updatable before we do anything to it. Yeah, so that's looking good. What other calls are here? I guess the rest of these will be left alone, but that was really it. And then update monster has never been doing anything, so goodbye to all of those.
Let's see, update familiar. Here we go. Goodbye. And that actually makes this a lot nicer to work with. And then I just go ahead and pull this out, and this would be the routine that basically holds all of our update calls. Again, a lot of people are always like, oh, you got to pull it out into a function, but there's no difference between a function and just a case statement, right? You still have a file that lists all these things, right? Whether
Yeah, it doesn't make a difference to me. It really doesn't. So we're not using either of these anymore, is that right? Math? Yeah. But, and I don't know... Oh, we're still calling update monster somewhere. And then we are shadowing that delta acceleration variable. So that's not good. Where else does it show up? Right here. So I think we can just get rid of that and it'll work fine. And then this doesn't exist anymore. So maybe now we're good. Nice. Or maybe not. I can't throw my sword again. No. Update sword. Shoot. Sword. Where did I go wrong here? All we did was pull this code out. Maybe it's because of the move entity call, because I don't think we were calling move entity oh no, we were. But we don't know the distance traveled until later. Okay. Well, we'll see how Casey handles this particular issue, because, well, yeah, no. I don't know why that would matter. Because we're not doing anything. Oh no, right here, because that's a pointer, and move entity is updating the position. So yeah, we haven't changed the entity's position, but we're taking the distance traveled. So I think the rock just keeps on going. Is that right? Because distance remaining is never less than 0. We can test this by, yeah, the rock will just go on into infinity and beyond. So yeah, that's no good.
their functions are inside a switch statement. But if you put them inside a switch statement, you have the option of having the preamble stack be shared, which is just so much nicer to work with, right? Yeah, so I don't tend to agree with people who want that, you know. It often just seems like a really bad idea. But, you know, I guess everyone has their preferences, so what are you going to do? So I guess what I'll do is, yeah, I'm just going to go ahead and pull this out. I'm going to put these things in there, and then I'm going to pull it out so that all of our entity update is just in one file, and it's basically a set of case statements, one for each guy for now. That's probably not how we'll do it eventually, because I've got sort of bigger plans for how I want entities to be composed, but that's a separate issue. All right, so now that this guy's in here, we can just have the move spec be set directly, and the DDP will also be set directly. In fact, we can just delete that, and now it works exactly as we thought it would, I believe. Let's go ahead and compile that. Process collision, that's not a real thing. Let's see, more than one. Oh, handmade entity. Let's get rid of that. Con hero. Okay, so now we need to do our actual call. We've got simulation entity, we've got our DT for frame. We've got the move spec, and so now we just need to change that to the regular DDP, and then I think we're good to go, right? Am I right about that? Ooh, what happened there? Move entity. non-spatial. Ah, right, forgot about that. So what we do have to do here as well is we have to make sure that we're actually only moving people who should be moved, which actually is not too onerous, because really that's just if DDPX or DDPY, right? If there was actually any movement that someone actually wanted, that should be sufficient to tell us, right? Because I think so. That would be my assumption, yeah. And that does look like, ooh, what's happening there? What's going on there? I've got something. There we go. That should not be happening. DT move spec. Oh, and you know what too? It's actually whether their velocity is there. That's the right. It's whether they have velocity or they have acceleration, not just whether they have acceleration. Although really, again, like I don't know if maybe we should have something. This is a little bit of a weird way to see whether an entity should be movable or not. We might want.
Okay, so yeah, that's. Why didn't I trip that assert? That's weird. I feel like I should have tripped that assert. Right? I mean, that feels like a problem. That I didn't trip that assert. But maybe there's something else going on there. What assert was that? That was asserting that they're non-spatial. Asserting that they're not non-spatial before moving them. I mean, I still have that move entity call. And you know what? That implies that his code is not having the same problem as mine. All right, because it means the sword is being set to non-spatial before, and that the rock is not just flying off forever and ever. So I don't know what he did differently for his to work where mine does not. But that's unfortunate. So, but yeah, I think that was right. That assert is written correctly. That's all I wanted to make sure. So we're asserting that we are not non-spatial, therefore asserting that we are spatial before we try and move an entity. Okay. All right, well, so we check to see if that is not 0 in the X or Y. And we do the same for the acceleration. Still a bit weird. Still a bit weird to me. Because I feel like Casey should definitely be having that problem where the rock never kind of goes non-spatial again.
They have acceleration. Although really, again, like I don't know if maybe we should have something. This is a little bit of a weird way to see whether an entity should be movable or not. We might want something a little smarter than that, but I don't know. For now, I suppose it's okay. We'll see. Gotta get a little further down the line. So that's a little weird. That guy doesn't look like we had, for our sword there, it didn't look like our sword was properly using its distance remaining.
Okay, never mind. He does have the same problem as me. All is well.
Let's see here. So if it's just make any non-spatial. So yeah, we also, now that I think about it, once something gets made non-spatial, this would move them back into spatialness. So that's probably not good either. So we may still need to check that. Now I think so. Basically, we may have to actually just say that we're going to still have a check on the flags there, and then only spatial things will actually get to do that. So we'll do that. We'll do if is set entity non-spatial, right? Then it can go ahead and do its move. Let me see if that's a little more sensible. I still don't understand why this guy can go forever though. That doesn't make a whole lot of sense for me. Shouldn't his distance? I guess I must have when I cut and pasted the code in there, I must have not updated everything. Distance traveled equals the entity p. Oh right, because now since we moved, we were counting on the fact that we knew how far it had moved since the last frame, but now we don't actually know that anymore. So that is the one place where we were counting on the fact that so far anyway, that an entity would actually get information about that. But we already had a bug of that form, which was that we essentially didn't handle the fact that inside a move, it shouldn't have been able to be allowed to move further than when the distance traveled timer would have happened. So what we really probably want to do is handle this in a more robust way where the collision routines actually understand the concept of a limit to the motion and will stop it at that limit. So I'm going to go ahead and say that that's something we can do tomorrow, and this will be our important to do for tomorrow. Add the ability in the collision routines to understand a movement limit for, for an entity, and then update this routine to use that to know when to kill the sword. Yeah, because that was a bug we already had. That's this to do down here, right? And so we kind of want to go ahead and actually fix that so that it's not going to do it that way anymore. And that's what we'll start with tomorrow. And then we can also finish our collision stuff. Figure out how we want to do that. We'll move this guy out as well. I think I want to put the to do in here.
Okay, so, wow. So we have, oh no, we still have that here. Huh. I had this to do kind of in the wrong place, I guess. Doesn't really matter, I suppose. But yeah, that's good. So we'll fix that probably first thing tomorrow. And well, he's gonna move one of these out.
We'll move this guy out as well. I think I want to put the to do in here. Move this out into handmade entity.cdp. And then that way we'll have a special place where all of our
So it'll be like one enormous update entity call, which is fine with me. I think that this has gone on long enough with this giant stretch of code. I'll just say move this out into the entity file. Because now it's looking pretty lonely. We just have these handful of procedures and there isn't much else to see there. But all of that will go into there, and then I think we're pretty much done for the day.
.cdp. And then that way we'll have a special place where all of our entity updates live, just so they're easy to spot and understand. All right, so that's about it. We can go ahead and go to the Q&A. I don't know how it's been going over there on the chat, but I guess now we will find out. Please prefix your colons. Please prefix your questions with Q colon, or prefix your colons with Q.
You heard it. You heard it here first. Prefix your colon with Q. So yeah, that's I would call today a W for sure. We still got a bit of an L with this arena, sim arena allocator stuff because it's not working. I doubt anything we did today would have any bearing on any of this. If I do this now and switch back to using the buffer arena from the memory we originally allocate in the platform layer, we're going to be all slow, and that's just sad. So I got to take some time to think about that, but other than that, everything else worked out great. I was able to diagnose like 1 or 2 bugs myself before the end of the stream, which always feels good. So yeah, thanks for hanging out with me for another day of Odinmade Hero. We'll be back tomorrow for day 68, which it's not showing up for me. Oh, exact enforcement of maximum movement distances. So just solving this problem that we saw here at the end of the stream with forever flying rocks. It's like a comet going through the universe, all lonely. It's going to crest just beyond the event horizon, and we'll never see it again. Bye, buddy. Good luck. Good luck out there. Yeah, so we'll be back tomorrow, and we'll keep on pushing ahead. Have a good rest of your day, and I'll see you then. Take care.